Welcome to another video. I've wanted to make VFX tutorials for a little while, but I've run into a slight issue where I was having difficulty finding a shader that would fulfill my purposes. I was having a hard time finding one that was free, easy to use, and would have enough settings and options. I guess shader is sort of like a good paintbrush if you're familiar with painting. If you don't have a paintbrush, you're going to be using like your fingers or something like the default particle shader. And you might be okay with that, but it's not going to give you as good of results as if you were using a real paintbrush. Don't think about that too hard. I'm sure it breaks down, but that's sort of the idea. So I needed to find a good shader, or as I will show in this video, show you how to make one and give it to you for free. This is some of the cool stuff that I've made with this shader. First off, jump over to your package manager. In here, search for shader graph. When you see it here, you can install it. Just click here, it'll be install instead of remove. Then, when you come over here to your VFX, you can create a shader from shader graph. So you can do a blank shader graph. Boom, we have a new shader graph. Problem is, when you open it, you'll notice a problem. Everything's pink. That's because shader graph doesn't work without a scriptable render pipeline. So how do we solve that problem? Well, we jump over to ERP or HDRP, whatever you prefer. So you go into render like this. We'll go to universal render pipeline, install this guy. And now we have a universal render pipeline. Awesome, but that didn't fix our problem. So jump over here to your project settings, and in your graphics, you will notice there's a scriptable render pipeline setting asset thing that you need to put in. So let's just jump over. Create, rendering, universal render pipeline, and pipeline asset. Cool. Now we've got a universal render pipeline asset. You probably want to put this in a folder like rendering or something like that. Next up, I'm going to recommend grabbing shader graph Markdown. This is a free asset as long as you are using it for personal use, non-commercial use. If you are going to use it commercially, highly recommend just jumping over there, grabbing this from the asset store. It's definitely worth it for what we are going to be doing. All right, to get started, just scroll down a little bit here to Quick Start. Click this link. It'll walk you through the installing thing. Just click Manual Installation and just follow the instructions. And now we have shader graph Markdown. So what does this do for us? Now in here, you'll notice our custom shader GUI should just automatically populate right there. So what does this do for us? It gives us more sorting options for our shader, which is going to be very, very nice when you have so many properties. When you save your asset with this in there, you'll see it's got these fancy drop downs, different titles, headers. It's got the full images. It's just a lot easier to use with all the organization going on here. And we will get into what all of this stuff does here very soon. All right, so at this point, you're probably wondering what exactly everything does in this shader. There's a lot of settings. So let's run through a few of them and just show you what they do. So these are a bunch of textures that a guy named Lewis has given out for free. I'll put a link in the description for where you can find these. They're really great and very useful, especially for my purposes here of showing you what this shader does. All right, so let's run through all the things this shader can do. First off, we got our typical tiling and offset. You can offset it, and this is animatable via an animator. Second, we've got scrolling, and this, you need to click on always refresh. If your animation stuff isn't working, make sure a lot of these are ticked on. There's also an animated materials one somewhere, but it seems to be working. So as you can see, it scrolls nice and fun, very useful. UV distortion. It's a fun thing like this. It makes give you some animation based on the texture you put in, which is super useful for making, making a little bit of animation in there. Next up, we've got Cutout. Let me turn off my distortion. And Cutout uses a cutout texture, or the texture that you're using, and it cuts it out based on the black to white values, which is super useful for getting a more crisp edge. If you want it to be crisp like this, it gets a nice effect. Or if you want it softer, that's fine too. But it makes your you can do a little more interesting decay stuff than just fading in and out, which is super useful. And you can use this the texture too. You can put in a custom texture to get it to fade out according to this texture. And you can set up the tiling and offset. You can make the distortion affected. Usually you want both of these on so that they distort together, but might have a good way to do it. And using Vertex Alpha lets you use it with particle systems. So the particle system alpha, like color over lifetime, for example, will affect the cutout value here. So then the particles will fade out along this over their lifetime, which is super useful. All right, now we're getting into, this is mask. This is kind of a more general thing. I would definitely recommend not using this. Use something called Vertex Colors, or setting up your textures properly the first time. This is more of a, if you need it, it's there, but probably shouldn't use it because one less texture map is more performant. Next up, Vertex Offset. I don't use this very often. It's kind of finicky. As you can see, it's very little. But what this is supposed to do is make the texture wiggle. So now you can see the actual mesh is wiggling here, which is cool. Can be useful sometimes. Maybe you've got a wobbly fireball or something and you want it to be wobbling. This is cool. This texture is not great for it, but you can probably find somewhere cool. Next up, we have soft particles. What soft particles does, let me throw in another sphere here. What soft particles does is it fades out when you are close to something. So this means you can get close to edges and it starts to fade. You can kind of see it when you turn off shadows, because that's really screwing things up here. Where are you? Oh, lighting. But you can see the edge fades nicely, so you can't really tell that there's a plane intersecting here. This isn't the most performant thing in the world, but it's not that bad either. Use it if you need to, but don't put it on everything if you can avoid it. All right, next up, Fresnel Edge. Fresnel Fading first. So Fresnel Fading is useful. Won't be very visible on this plane, so let me throw this texture on, where did I put that? Sample on the sphere. And you can see it fades the edges so that it doesn't look like a sphere anymore. Or it doesn't look like it's a hard edge sphere, so it looks like the edges are soft, which is very useful for meshes when you want to make, when you want that. And this does work with Cutout. Look at that. So now the edges of your sphere can cut out with the cutout stuff. It's not super great with the cutout stuff, but it does work and it looks pretty nifty. Okay. So you can see that this one, it makes the edges all glowy, which is nice. And you can make it additive or multiplicative. You change the color, make it all HDR. If you haven't set up your post-processing, this will just blow it out, but that'll give bloom if you crank that up normally. And you can switch it between there and make it stronger or weaker. All right, so with all of these settings in mind, let's figure out how to make it. Okay, so this is our shader. It's huge. There's a lot of stuff going on here. And it gets worse because many of these are actually subgraphs. And there's a whole bunch more nodes inside them. So let's break it down a little bit on what this works. First off, if you don't know how to use shader graph, hit spacebar to add a new node, type in what node you want, hit enter. So if you want to sample texture 2D, you just type sample 2D and put it in there. Then you can drag nodes in, whatever. Cool. Okay, second off, to use needle markdown, there's documentation, which is fantastic, but you can just do what I'm doing. You've got the hashtags and the double hashtags that give you different settings. So first off, we go through our UV distortion here. That's one of the first steps. We combine that with our scrolling texture. This is just the scrolling texture stuff right here. We combine that in, we make a decision on whether we want our UV distortion or not. Put it into our main texture, and that's right here. Now the main texture splits off into multiple different directions here. First off, we go up here for the color. We have a Fresnel Edge and adding Vertex Color to our color. So this Vertex Color is particle systems. Particle systems decide the color based on the vertex color. So if you let your shader listen for the vertex color, then it will add the particle color to the material, which is perfect. And then we throw that into the base color on our shader. And this transparency stuff is a lot more complex, so I will run through that a little later on. But that's the gist of how the shader works. So let's break down more specifics. So diving into our UV distortion layer. This is what it looks like. It looks a little scary, but it's not that bad, I promise. What we need for this one is we need a distortion texture, and we need a tiling and offset. I put this in the XYZW, so I use all 4 values, because if you just use a vector 2, it has the extra values Z and W there, but they don't do anything, which is really annoying in my opinion. So I just set it up like this. And then we also need distortion speed and power. So what tiling does is it'll be like how dense your distortion is. The higher the tiling value is, the more of these there's going to be. Kind of see it changing there. And then the offset just kind of moves it off to the side. I'm not sure if that's really all that useful for the distortion since it's scrolling anyway, but it's there. It's easy to hook up if we ever need it. Then the distortion speed and power. This is how fast the distortion goes. So if I put it down a lot lower, it scrolls a lot slower. And if it's, more powerful, then it gets more bright. And you can see how that'll affect it later, but just as long as this is working like that, that's exactly what we need. So how do we set this up? So these two sections are very similar. Just one of them is doing X and one of them is doing Y. Like this one scrolls up and down, this one scrolls side to side. Cool. So what we do here is we input one texture over here. We'll get to that in a second, I suppose. And the texture is being scrolled randomly in a direction. One of them goes up, one of them goes down, and then they are multiplied together. So what we want to do here, all of these little guys are just to make it a little different from each other. So they aren't perfectly overlapping. You can see I didn't do it perfectly here, but I can adjust the values easy enough. So essentially what's going on here is we're taking the tiling and offset. We just want the XY for starters here. We combine those into a new, use a combine node to combine them, split that out into our tiling nodes, 2 of them here. So this just makes it so that it's higher or lower tiling. And you'll see that if I click these in here. Now they've got higher tiling. It looks a little, you can see it better over here where they're scrolling. But that's what that should do. Next up, our distortion speed. We split that. We only want the Y speed for this bottom part. And put that in here to our vector 2. And just, since we need to input it into a vector 2 because we only want one value. And then we put it into the multiply node here, and we multiply it by time. And that gives us our scrolling, our offset, which you can see is panning it here. Top one is very simple. Bottom one, we just add a few random multiply and adds here to make it scroll. Well, first there's a -1 somewhere right here, and it's scrolling at a different speed. So it hopefully doesn't line up perfectly. I obviously need to fix that there, but that's the idea. Then up here, we do the same thing, except for this time we're taking the Z power and the X speed. We're just taking the X speed, the powers in a second. And I literally copy and pasted it, changed a few of the values down here, and now these ones are scrolling left and right instead, overlapping hopefully very little. All right, so now we've got these 2 scrolling textures that are going in opposite directions. That's great. Now we need to actually take the power. So we want to take our It's useful to have the powers different, just in case, but you'll oftentimes have them be the same. So for example, if I make the power a lot higher on one of them, the directional movement in one direction is higher. At least that's the idea. So we split that out. We only take the power, we multiply it by their respective powers, we add them together. You want a bit of a gray texture, something like this. And then when you add more power, it should get more white. And that's the idea. And it's fine if it goes over 1 because that just makes it more distorted. And then we stick that into our output, and that comes out here. So as you can see, that's exactly what's going on, but it makes this whole area nice and tidy. So I don't have all those extra nodes here. The UV distortion is just what we do. Okay, so what's going on up here? We've got our scrolling main texture. So this is where the basic scrolling comes in. Our tiling and offset, we want to start with that because we want it to be off a little bit if we want it to be offset. Nice and easy. And our tiling, this is just the basic, like at the very top of the shader, you got your tiling and offset. This is where this input's here. We want to split that into our separate values. So we'll combine it, split them and then combine them. We want to split them into, tiling and offset. If you made them into a single vector 2, you can skip this section, but I think it's easier to use if you keep it all there. And same thing. Okay, so then if you didn't want to have any scrolling texture, you just plug this stuff directly into you plug this one directly into the offset, just like that. But if you want scrolling, and I do, all you gotta do is a couple of extra nodes here. So first we need a speed, scroll speed X and scroll speed Y. We combine those into a vector 2, vector 4, put that into our multiply node, multiply that by time, output it, add it with our offset here, and then put it into our tiling and offset. So in theory, it's always trying to scroll it, but most of the time you're gonna have it at 0. Okay, so we have our tiling and offset here set up nicely. We can combine that with our distortion just by adding it, nice and easy. Then here, we want to decide whether to use it or not. So that's where we have a bool that's exposed in our shader. This is just a bool. You want it exposed and the default probably off because you probably don't always want UV distortion. But then you just plug in the values. If the bool is true, then we'll take our distortion. If it's false, we just want our normal tiling and offset. Nice and easy. And then we plug this branch into our sample texture 2D. This is our main brain texture here. This is our base texture. This is the original one that you put at the very top of the shader. Plug these in together and you already have a texture that will work, or a bit of a shader that will work. Might not be perfect, but it'll work. So let's run up through the colors real quick. So color, first off, this is just a color value. Just color value, that's all it is. You want this to be multiply. It just works better than additive in this situation. You can make it HDR, and so it will blow out and get more exciting. So you can get basically additive anyway. Okay, next up, we're multiplying the color there, that's what that is. Next up, we got our Fresnel Edge. This is the part where it's on the edges, it can glow a different color. Super useful. So we got a bunch of these inputs going in. Let's dive in and see what they actually do. So first off, Fresnel power. This is simply, you can see here how drastic the edge glow is. Useful. Fresnel Edge color. So this is just setting the color. If it's set to black, then that's not really going to be very visible. So if you set it to red, you can see it multiplying together. So later on, so we want both things here. So we want to have two options. We want to have an additive or a multiplicative. So it makes it brighter or darker depending on which one you choose. So in order to get the additive, we want it to look something like this. That's just normal. We multiply the color with the Fresnel effect and it's additive. Look at that. So now we can add this to anything and it'll just take the red edge and it won't care about the middle because it's black and transparent. The inverse, we want to 1- it so that it inverts the Fresnel effect. So now you can see the edges are black. Then we screen it, so we make the edges a little bit lighter, and then we will multiply it, which only takes the lighter bits, or the darker bits, sorry. Now at this point, we will branch and pick. So this is just deciding if you want to use additive or not. So you just have a bool for additive. If it's true, then you take the add one. If it's false, you take the multiply one. And then I have another branch that does the same thing. I don't know why that's there, but don't worry about it. You can skip that step. Then over here, we've got a branch that decides if we actually are going to use this or not. If not, we're taking this vector 4, which is our image that we input, the base texture. And if we don't want to use it, then we just do false and stick it right back out. And if we do want to use it, then we'll swap it into this version that we have added or multiplied to our main texture. Pretty easy, pretty simple. All right, jumping back along, moving right along. This one, I already explained a bit. This is taking the vertex color, either from your vertex painted mesh or from the particle system, and multiplying that with your texture. Then we send this all out to the fragment shader, fragment section thing here, and that's your base color. Nice and easy. All right, before we jump into transparency, let's just jump in this vertex offset real quick. So we've got a few settings here. We've got our scroll speed, we've got our tiling, we've got our texture. So this stuff's pretty simple. It's basically the same thing that we did with the main texture already. We're setting up the scroll speed, multiplied by time, multiply the tiling, or set up the scroll speed and the tiling into a tiling and offset. So now we got our tiling and offset with our sample texture 2D. And we want this to be a LOD. So I'll just show you the scroll speed. Well, we need to start with tiling so that it's 1 and 1, so you can see it actually. Then the scroll speed, we'll just make it like 0.5 or something. And then our texture, we'll just throw in a random texture. So now you can see it's scrolling. Perfect. Over here, now we have an intensity value, a vertex offset local intensity. Set it to 1. It should be like gray, something like this. Multiply it by 0.1 because it's too big. The values are too difficult to work with. You don't have to do that, but it just makes it easier later on when you're actually working on it. Set the strength to something, multiply that by half. Again, just makes it easier. So what you want to do here is that's an extra note, is what you need is position, which takes the position of your vertices, and multiply that by all of this other stuff. So run this through a contrast node and then multiply it together. And then eventually you will, multiply that with your normal position. And then we have a simple decision over here. If we're going to use vertex offset, then use the vertex offset. If not, just use our normal object position. Great. Send that out and plug that into your position on the top section of the shader here. All right. Now we get into the juicy stuff, the transparency. This is going to be a little bit complicated, so hopefully I can explain it well enough. The reason this is so complicated is because there's lots of sections that I want to potentially affect the transparency of my particles. I want soft particles to work at the same time as cutout works. I want, some of these other things to all work together. I want the mask. I want the alpha from the texture to apply, even if I'm using a mask and cutout. So let's start here with our cutout. I know this looks like a weird spot to start, but this will make the most sense when I explain a lot of the other nodes, what's going on here. So jumping into our cutout texture. This is fairly simple, straightforward stuff. So for now, we've got our smooth step. It's fairly straightforward. All we've got is a smooth step here that's doing the brunt of the labor, and I plug the texture in to kind of show you what the different things do. So we've got a cutout edge sharpness, which we want to add to something just before. But the cutout edge sharpness obviously makes it smoother or harsher and inverts it if you go too low. And then over here, we've got our cutout value that, as you can see, just changes the value of it. So what's going on here in this little section? we've got our decision on whether we want to use the cutout value, the slider, or if we want to use the vertex color. Most of the time, you're probably going to want to use the vertex color. But if you have an animation or something, if you set it up via animation rather than particle system, you can certainly use the cutout value. So we take the vertex color. We only want the alpha, obviously. Turn it into a 1- to invert it. Send it over here to the true section. And the branch, this is just a bool deciding if you want to use which one you want to use. You send whichever one you want to use over here to the edge. You add a little bit to the edge, add something to it to make the edge sharper or not as sharp, and put that into the second value here. And then it should work really nice. So you send an output there. Perfect. So how do we get to this point? What is the guide just before this and after this? So you could plug this right in to your alpha and it would work, and plug this right into your texture and it would work. But you're going to want a little more control than just that. So what do we do over here? Let's back up a little bit from the cutout. So this is deciding if we want to use a separate cutout texture. Do we want to use the base texture as your cutout guide or a separate texture that you input on your own? Both are great. You're going to want both. So we just have a simple branch with bool deciding it. If it's false, we take the base texture, alpha, just to show you it goes all the way back out here, the RGBA. You'd run all of them, probably not just your alpha value. And then if it's true, then you take this previous texture. This is a cut. So inside this is really simple. We've just got our cutout, tiling, and offset. Normal stuff. We've done this before. Tiling and offset. Adding it to the vector 4. The vector 4 is your distortion subgraph. You can see vector 4, adding that here. So it'll be a little bit animated. And then if you want your distortion to affect your cutout, then you will take this one here. If you don't want it to affect it, then don't do that and it'll just be false. Then you've got your cutout texture, sample texture, put your UVs in here. That sets your tiling and offset and your distortion if you so desire. So yeah, that's not actually all that complicated. And we've gone through the bottom bits here. Nice and easy. Okay, we're going to jump back over here to look over here at this thing. So this split is looking at our color that we've chosen. Will make your color chosen respond to transparency. So over here, we're just taking the alpha. We're multiplying that by, you probably guessed it, the alpha on your sample texture. So this makes your whole texture respond to the alpha that you decide on your material, which is really, you need that. And then here, we are multiplying this by our mask. This use mask is super simple. You've done this before. We've got our splitting, we got our tiling and offset, we've got our mask texture. We can decide if we want to. If we want to use our mask, make it true. If false, we want it all to be white. Because you don't want to multiply anything on there. And if it's fully white, it's 1, you're multiplying by 1. That doesn't do anything. Just has the same result. Okay. Now we've got our Fresnel Fading. This is a little more complex, but it doesn't look complex. This took a minute to figure out. Basically, what we're doing here is we got our fade power, right? And we got our Fresnel effect. You want world space on both of those. You want 1- invert it, power of 5. I don't know why, but having a power of 5 works great. You can make this a variable if you want to be able to edit it, but 5 works great. And you want this power node. If you don't have this, you'll get some funky results. So do that. Then we have a simple branch Boolean if we want to use it or not. Okay. Then we multiply that together with our previous one. So now we can use a mask with a value on our color and our alpha texture, our texture's alpha, and the Fresnel fade will all work together right here. The one thing we're not really paying attention to is our vertex color. So that's like your particle system. does your particle system fade out over time? You probably want it to in some way or another. So we split that, we take the alpha, and we multiply that with everything else we've done so far. And we've got a whole bunch of things that can affect our alpha, which is exactly what we want. Then we'll follow this trail over here to the cutout section. This is where we decide if we want to use cutout. Remember this, we set it up before. So we'll slot these in, decide if you want cutout or not. If not, obviously true or false, set it up how you need to. And then send it up here to multiply. Another multiply, our last one. This is where soft particles come in. You want soft particles to be last. So what are soft particles? We already talked about that. They make the edges softer when you run into walls and stuff. So how do we do that? This is also a little bit weird, but it works. So we want scene depth here. We're taking that, sample linear, multiply that by our far plane, subtract that from our screen position alpha, raw, then multiply that by the power of your soft particles, saturate it, which clamps it to 0 and 1, between 0 and 1. Then we have a simple branch if we want to use it or not. Nice and easy. Input that, multiply that with all of your previous ones all together, and stick that into your fragment alpha. All right. A couple of little connections here that we didn't go through. At your base alpha with Vertex Alpha, you want to put this in here because you want your cutout to think about all of this other stuff. You want your cutout to respond to all of your other alphas that you have figured out here. So you plug that in here to your cutout. When you multiply it with your cutout texture decision. Okay. We have successfully gone through the entire shader, and I've probably confused everybody who watches this video. Well, that's why I'm going to make this available for anybody to use. And if you follow the first bit of the video, you should be able to get it set up in your project without too much issue. One thing, final things you'll need to know about your shader is in here, you'll have unlit. You'll want it most likely to be unlit. It's more, it's better for performance if it's unlit for one, and two, generally will look a little better if your particles don't have shadows from like the player on them. You can try it if you like it, but that's my recommendation. All right, then here in our blend, we've got alpha, additive, multiply, and pre-multiply. This is a really annoying thing that Unity does not just have in the shader options. I can't make a tick box to switch between alpha and additive and multiply. You have to do it in the shader. So what you'll have to do is set up your shader exactly like you want it, and then make an alpha one. Then you save it, and then you'll change it to additive and save as. So now you have two different shaders that do basically the same thing, but one is additive and one is alpha. Alpha blended is just like your normal blend mode layer. Additive is like your screen blend mode layer, if you're familiar with Photoshop. Secondly, double-sided. You're sometimes going to want double-sided. You're sometimes not going to want double-sided. So that's another variation of the shader you're going to have. So at the end of the day, you might have 4 different shaders here that do basically the same thing. That is another really big benefit of breaking a lot of these down into subgraphs, so that if you edit this subgraph, it'll change it on all 4 shaders, like this one where I forgot to put it back like that. So that essentially is the breakdown of this shader. This is over-engineered, I suppose you could say, and there's way more stuff in here that you would need. Many of this stuff you won't use all that often. I don't use Vertex Offset very often at all, but it's handy to have. Before you ship this shader, I would highly recommend checking out the performance impact of it and potentially trimming it down in places you don't need it. But for just testing and experimenting and practicing your VFX, this should work really well for you. I'm hoping that a lot of you are able to find good use out of this and in my future videos too. So thanks for watching and have a fantastic day.